Good day, viewers. This is 300 Plus Academy, where all we do is exams, tutoring, ensuring that you ace your next exam. Straight to the business of the day, it's going to be about 2024 NECO Physics Practical. This time around, talking about first board experiment. As you can see on your screen, this is exactly what your setup should look like. The things we are going to be supplied with in the course of this practical physics exam is a drawing board, mass hangers, that's what we use in hanging masses, threads, that's just about it. Masses, one of the masses is going to be labeled either W or MO, or as the case may be. You're going to be supplied with several masses and of course two pulleys. Now, in the course of this experiment, one of the pulleys is going to be fixed at point A, and then another pulley is going to be fixed at point C. So in this experiment, you're going to be given mass MO, which you're meant to, one of the ends, you're meant to, okay, if this is your mass hanger, if this is your mass hanger, one of the end of the thread is going to be wound round the mass hanger, while the other end, this other end is going to be, tied at A, and then the other end is going to be our NC, and then you see we take this, we bring here, so that this is what we are going to have. The moment we hang it and this passes through the groove of the pulley at point C, what we're going to have is that we're going to have a tension in the string, in the thread, and behind the thread is where we are going to set up our drawing board, as you can see on the diagram on your screen. Now, just behind it, then according to the instruction, look at the question on your screen. For those who wants to perform the experiment, the instruction is there. Attach the mass MO to one end of the thread provided. Fix the other end of the thread to the pulley on the on the first board. Pass the thread through pulley C. You see the pulley on the first board, and then the other thread is going to pass through the groove of pulley C. Hang the first board vertically. Fix a drawing paper on that board behind it. That's exactly what you can see on your screen. Draw a line on the paper along the direction of AC. So in the course of this experiment, it means the expectation is that each candidate is expected to be given two pulleys, a drawing board, several masses, and in centers where there are 200 students, 150 students, we know that this is not obtainable, and that has always been the bane of many students. That is why the approach we are going to be using for this, and which I believe with it you're going to ace this exam, is going to be in a smart way. It's going to be in a smart way where you can get around all of the processes. Now, this is it. You're told to hang this setup this way, and then you're told on your paper, look at the instruction 3. Draw a line on the paper along the direction of AC. We have to draw a line on the paper. So let's say this is our paper now. We have to draw a line indicating the distance from A to C, the distance of the pulley. So I'm going to take this as my, okay, this is my A. Let this be my A, just saying, on the board, and let this point be my point C. Okay, so if I'm drawing a straight line to represent AC, okay, let this be my A, let this be my C. So let's say this is 20 centimeter, this is about 20 centimeter, just saying. I was told to identify the midpoint. The midpoint of this is going to be about 10. Okay, let this be my midpoint. My midpoint is B. I've been able to do that. That is what the instruction says. Draw a line on the paper along the direction of AC. Locate and mark the midpoint B of line AC, draw a normal to AC at B. When they say a normal, it means a line perpendicular or at 90 degrees to A and C. Let this be my line. Let this be my normal. Okay, I've been able to do that successfully, on my paper. Now that I've done that, what is the next instruction? By means of a loop or the suspend a mass M, which is equals to 10 grams from AC, adjust the position of the loop so that the line of action of the weight M lies along BP, the normal to AC. Okay, they want it along the line BP. Okay, let this be my BP, and this is the normal on AC. So what they are telling me here is that I am going to be, having another thread. I'm going to be having another thread, and then I'm going to hang I'm going to wound this round, a mass hanger carrying a mass of 10 grams. Carrying a mass of 10 grams. So I'm going to be taking this, I'm going to tie it exactly at point B. This is my point B. I'm going to tie that here. So immediately I hang my 10 gram mass, over the thread. I hang that at point B. Then it means that this here is going to descend downward. It means there is going to be tension in here, so that it was here before. This is the position of the thread before. Here I have my W, or what we call our mass MO. That's our mass MO. So the moment I attach this particular thread with the mass 10 grams at point B, and I ensure that it is in line, with the normal, then this is what I'm going to have, so that here the mass the mass MO, which is equal to G. I was not told what that mass is actually here. You need to understand that the weight is acting downward. Weight is equal to mg, is acting downward at this point, and then you're going to have tension. Actually, there are tension in the string, and the tension is all equal. So you need to understand that the moment we do this is acting downward, and you need to understand that this here, there is a tension in here, and the tension in here and the tension here, they are going to be equal. Yes, the tension will be equal, and this is acting, this way. So that what we talk of here is more like equilibrant of a force. So the next instruction they want from us, before I show you how we are going to manipulate our result, it says, by means of a loop of thread, suspend mass M equals to 10 from AC, adjust the position and make sure, okay, we have all of that. Ensure that the mass M and MO hangs off the force board. So you make sure that the mass 10 gram and the mass MO, which, it wasn't disclosed to us, we make sure that it is not touching on the board. Trace the part AO. Well, now this is our O. This is our O here. As you can see in that diagram on your screen. Trace the part AO. Trace the part OC. Shit. Trace the part AO. Trace the part, we're told to trace the part AO. Trace the part OC. And then OP. Now, OP, that line we drew up to P, up to point P. We're told to trace the line OP. Just trace the line, that's all. Now, of the thread, measure and record Y equals to BO. Okay, Y equals to BO. This is our point B here. Y equals to BO. We're told to, measure from here to this point here, BO. Also measure and record D equals to AO. BO and then AO. We are measuring here and we are measuring from here to here according to the instructions that we have here. But the question is, and which is likely what will happen in a center with about 200 students, how do you go about this? How do some students will not even be supplied with pulleys? So how do you get your way around this? It is very easy. Now, and the key to this is the fact that you see this mass MO that you're going to be given tomorrow is actually 30 gram. And with this 30 gram, we actually can manipulate every of all this bulky information. We can get our way around this. Mass MO is actually 30 gram. If we try to convert this to kilogram, because we deal in kilogram in physics, so MO is actually going to be 30 divided by 1000. So that way we would have 0.03 kilogram. So the weight here, which is equal to the tension that we have all along the thread, the weight here, weight is actually mg, and that's 0.03 times 10. That's going to give us 0.3 Newton. So what that means is that what we have here is 0.3 Newton. So what this means is that all along the thread, the tension, recall that I have said the weight is 0.3 Newton acting downward, and all along the thread, the tension in there is 0.3 Newton. So that what this means is that, so if I try to resolve this here, 10 gram here, if we work out this 10 gram, following the same, convert the 10 gram here, that's going to be 0.01 kg. And so the weight here, let me call the tension here TO. So the weight here is going to be 0.01 times 10, and that's going to be 0.1 Newton. So that's what I have. Now, if we try to resolve this, the tension here and the tension here, they are equal. Okay, let this be our horizontal. Now there is an angle here. There's an angle here, and the angle we have here and the angle we have here, they are equal. That's they are alternate angles. So I could actually resolve this T so that this T, I get the vertical component. So that what it means is this. What this means is this. Where this here acting downward is 0.1 Newton. Now, if I resolve this tension, this is more or less like vertical components. This is vertical, this is horizontal. Vertical component, this here is going to be T sine theta. And then this here as well is also going to be, the angles will be the same, T sine theta. So that's the sum total, T sine theta, T sine theta. Altogether, that is 2T sine theta. And downward here, I have 0.1 Newton. Now, the weight acting downward here and the tension in here, which is the same all through, is 0.3. That's for the MO, is 0.3. So what this means is 0.2 times 0.3 sine theta. That's what we have on the upward, and this is what we have on the downward. So if we say 2 times 0.3, that is 0.6 sine theta equals to 0.1. So then it means that sine theta equals to 0.1 divided by 0.6. So theta, in this case, remember we started with 10 gram here. Our theta is going to be equals to the angle equals to arc sine 0.167, and therefore the angle here is 9.6 degrees. This is approximately 10 degrees. So all I need to do that way is that I'm just going to get, now that when I use a mass of 10 gram, I got an angle of 10 degree. Now the real formula we need to use, sine theta equals to what? When I use 10 gram, it was what? 0.1 divided by 0.6. It's about you getting the angle. With the angle, you'll be able to draw the right diagram on your paper, even if you don't have access to the whole apparatus and you know the way the lab is during physics practical. This is what you need to remember. Sine theta equals the mass you are hanging from point 0 here. You're hanging along from the normal at B downward. If it is 10 gram, that means that's 0.1 Newton. Look at the way I converted it to Newton. First, you convert it to kilogram by dividing by 1000, and then you convert it to Newton by multiplying by 10. I got 0.1 Newton. So if it is 20 gram, that's going to be 0.2 Newton. So, and according to the tension that I have here, that's the two things I matched together here. I got 2 times 0.3, 0.6 sine theta equals to what? 0.1. Upward force equals to what? Downward force. For this to be in equilibrium. That's why we talk about equilibrium here. The force that just counterbalances each other. So this 0.1 is from the mass that I hung at the center, from B. So when I'm hanging 20 gram, that's 0.2 Newton. So what I need to do here, that will be 0.2 divided by 0.6. That will give me 0.333. So arc sine of that, I got 19.5 degrees. So with this 19.5 degree, there are things I am going to achieve with it. So to conserve time, when we walk through all of this using this particular formula, sine theta equals to, what is the weight, converting the mass to weight. When we slot in the weight here, divided by 0.6, and we look for the arc sine. These are the angles we get. So after doing that, the next thing you're going to do is that from point A here, you're going to get your protractor. From point A, you're going to get your protractor. After getting all of these angles, you're going to get your protractor. You place your protractor at you place your protractor at A, and then you have to trace out, you have to put markings for all of this point: 10, 20, 31, 43, and 58. 10, 20, 31, 43, and then 58. Now, I've been able to get all this point, and that's exactly the diagram you see on the paper, but I just have to display this on the board. That's exactly the diagram you see displaying. I performed on the paper, and you have to just trace this out. See, from point A, you trace this out to the normal you drew on your paper BP. This here is going to mean this, and then this, and then this, and then this, and then from the end A to touch on the markings from the protractor. So this here represents what I expect to have on my paper, and once I have this, I am done with things. Look at it very well again. Based on the masses you're given, convert the masses to Newton. When you convert the masses to Newton, slot it into this formula. Whatever Newton weight you have here, whatever force that you have here, put it here, divided by 0.6. When you divide this by 0.6, look for the arc sine of that. That's going to be the angle. Come back to point A. Come back to point A. Your point A to C can be 20, can be 15, can be 17, can be 18. Get the midpoint, draw your normal, make sure it is perpendicular to this. Based on the angles you get here, come here, get your markings and go with it. And I tell you, you cannot go wrong. Looking at the remaining question, do not forget sine theta equals to whatever weight it is we have. In this question, we're told to use 10.0, 20.0, 30.0, mass 40.0, and mass 50.0. So for us to get the right angle, just convert this to weight, divide the weight by 0.6, look for the arc sine of that, you get the angle. With that angle, place your protractor here, the center here, you know, mark the respective angles you got, and then trace that to the normal you have at BP. So the distance O is along the line BP. So if you look at the instruction there, we were told, if you look at the instruction on your screen, we were to measure and record Y equals to BO. So this is supposed to be our Y here. Y equals to what? BO. And this is supposed to be our D here. D equals to AO. So talking about Y equals to BO, from a B to this is all point O. From B to O, 1.80. From this point B to the O, when the mass was 20.0, that's 3.60. For what we got on paper, for the third one, Y, that's talking about B to O, was 5.80. When the mass was 40 gram, we got 9.20, 9.20. We got 9.20. And when the mass was 50, we got from B to O, we got 15.70. So that is measuring Y. Talking about measuring the D equals to A to O. So when we measured on paper, what we got was 10.10, and then we got 10.50. And then for the third one, when the mass was at 30 gram, we got 11.40. And for the fourth one, when the mass was 40 gram, we got 13.40. And for the fifth one, when the mass was 50 gram, we got 18.50 when we computed that. So that just ends that. So that is why you just have to know how to manipulate and get around this. So we're told to express L equals to Y over D. Of course, when you say L equals to Y, L equals to, of course, when you say L equals to Y over D, Y is in centimeters and D is also in centimeters. Centimeter takes out centimeters, so this has no units. When we compute this to 2 decimal places, this is 0.18, and this here we got 0.34, 0.34, 0.50, and 0.69, and lastly 0.85. So that just ends our table recall. And don't forget that the main thing here is you knowing how to get around, and this is the key thing you need to manipulate. How do you convert your weight, your masses to weight? Normally you have to say, okay, for you to get it your weight, whatever mass you're told to use tomorrow, divided by 1000, multiply by 10. So in the case of 10 gram, that will be 10 over 1000 times 10, and this would have given you 0.1. So you put 0.1 here, 0.1 divided by 0.6. Look for the arc sign, come here, trace that out. When it is 20, you get 0.2. 0.2 divided by 0.6, you're going to get a figure here. Look for the arc sign, come trace the angle out here on your paper, because you're going to also be submitting your paper along your exam, alongside your exam sheet. So that ends that. So the next thing, as you can see in the question on your screen, is we're told to tabulate our readings. We've done that. Plot a graph of L on the vertical axis and M on the horizontal axis. L on the vertical axis and then M on the horizontal axis. The first thing you ought to do is to write your title. This is graph of L. L here means y over d against M in grams. The next thing for me to do is to draw my vertical axis. The next thing for me to do is to get my vertical axis down, no broken lines, you just go once. Yes, I've been able to do that. Okay, my vertical axis talks about L. I can just leave this as L. No point writing my y over d again. Okay, I might if I want y over d, but it has no unit. And when I look at it, 0.18 to 0.8, 0.18 to 0.85, if this is my zero origin, just saying, if this happens to be my zero origin, then it means that if I say 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, I think I'm going to be able to use that. So I'll take this as 0.10, 0.20, 0.30, 0.30, 0.40, 0.50, 0.60, 0.70. Remember that your graph must cover at least 70%, 0.80. I've been able to, then this is going to be my 0.90. That's based on the size of my own graph. Then my mass M is 10 to 50. So this is 10, 20, 30, 40, 50. 67, 89. Okay, for my own graph, I'll be using from here to here. From this point to this point is 2 centimeter. So on your graph, you should be able to use 4 centimeter to represent 10 gram. But for my own graph, I'm going to use just 2 centimeter to represent 10 gram. That's because of the size of my graphs. The next thing to do is to draw my horizontal axis. Yes, we've been able to do that, and this here is going to represent, okay, mass M in gram, mass M in gram. So I'm taking this to mean 10.0, 20.0, 30.0, 40.0, 50.0. So this is going to be a direct graph. Next thing is to pick my point. When L is 0.18, this is 0.18 and 10, 0.18 and 10. This is my point. And then 0.34 and 20, 0.34, 0.34 is somewhere here, and 20. And then 0.50 and 30, 0.50 and 30. I've been able to pick that. 0.69 and 40. 0.69 and 40. Yes, I've been able to pick that as well. And 0.85 and 50. 0.85. 85 is somewhere here and 50. So I've been able to pick my point. So the next thing is for me to try to get the line of best fit. And when I do this, yes, with this I'm able to pick, I think, about 4 points. So this here is my line of best fit. Yes, look at it. I was able to pick 1, 2, 3, 4. Just one. Slightly missed out on one, which is okay. So let's move on with the question. We've been able to plot the graph and we were told to determine the slope S of the graph. Okay, in getting your slope, okay, don't forget for your graph, you have to tell us about your scale. Your scale is important. So at the corner of your graph, you just must indicate your scale. Starting with the vertical axis for L. What I did for this graph for L is I've used 2 centimeters to represent 0.10 units, 2 centimeters to rep 0.10. No, this has no unit, so that's just okay. And then for my M, which is in grams, I've been able to use 2 centimeters. Look at it. 2 centimeters to represent 10, to rep 10 grams, to rep 10.0 gram. So my scale is already there. So for me to get my slope, I can just, okay, I can go this way. I need to draw, you know, something that looks like a right angle, you know, for my change in the vertical axis divided by my change in the vertical axis divided by the change in the horizontal axis. If you've been following this channel for some of those things, by now you should know how to get your slope. Yes, I've been able to do this. Now this here is change in M in grams, and this here is my change in L. No unit, change in L. So when I look at it, I have to just trace this out. I can use my extrapolated line. You draw with your ruler. This is where your y stops. This is 0.20, and then here, which is 0.85. So you can draw your extrapolation, that's your broken line, so that you just catch that out. You know, you draw your broken lines. So that's 0.85. So we know quite well that slope equals to change in L divided by change in the mass in grams. So the slope here is going to be, change in L is 0.85 minus 0. This is 0.85 minus 0.20, 0.20 divided by, okay, let's try to get this. Okay, this here is 50. This here is 50. This point here is 50, and then this point here is, no, this point here is 10. This is 11. Yes, 11. So this is 50.0 minus 11.0. So 0.85 minus 0.20, we're going to get, our slope is going to be 0.65 divided by 50, take away 11, that's going to be 39 gram. And when we divide this, our slope is going to be, when we compute this, the slope is 0.017 per gram, because the gram is down, so this is what our slope is. So that ends the graph. We look at things you need to take note of: the title, the vertical axis, the horizontal axis, line of best fit, picking your plots, the slope, making sure you get the point, and also on the slope, making sure you get the right unit. So that ends that part of the question. The next question we have says we should state the precautions for this experiment. So what are the precautions for this experiment? It is the same. So what are the precautions we have for this experiment? We must ensure that the first board is firmly clamped or fixed. We must avoid parallax error when taking our readings with the meter rule, when measuring AO, when measuring BO, and the likes. We must ensure that we avoid parallax error. We must ensure that the mass M hung from the perpendicular, that's the normal at B, and the mass MO, which is fixed all through the experiment, is not touching or resting on the board. And also, as you can see on your screen, we must avoid zero error on the meter rule and correct correspondingly. So we'll be told to list two. So just pick out any two that flows with you and put that down. And the next question says we should state the parallelogram law of vector addition. The parallelogram law of vector, you know what it states. It states that if two vectors are represented in both magnitude and direction by adjacent sides of a parallelogram, then the resultant is going to be a vector represented in magnitude and direction by the diagonal of a parallelogram drawn from the common point. So that says that. And then the second one, we were told to state the condition for equilibrium of a body under the action of a coplanar parallel forces. So what are the conditions for equilibrium? You can think in terms of forces. Upward force equals to downward force. When we wanted to manipulate this experiment, recall that it was one of the things we used. Upward force equal to downward forces. And also you can think in terms of moment. Sum total of all of the moment equals to 0. In other words, clockwise moment equals to anti-clockwise moment. And with that, we have come to the end of this probable question talking about NECO 2024 physics practical. For myself and the entire team, it's bye for now.